The world is a diverse place. Animals vary in size, from the tiniest insects to the largest mammals. Plants differ in height, from small shrubs to towering trees. Even seemingly identical objects like grains of sand reveal subtle differences upon closer inspection. Each grain has its own unique shape and texture. This inherent variability is fundamental to life itself. It is what makes ecosystems robust and adaptable. In our quest to understand the world, we often turn to statistics. Statistics help us make sense of the complexity around us. We collect data, calculate averages, and draw conclusions. These averages give us a snapshot, but they don't tell the full story. Yet, without understanding the spread or dispersion of our data, our insights remain incomplete. The spread tells us about the range and distribution of our data points. This is where standard deviation comes in. It is a statistical measure that quantifies the amount of variation or dispersion in a set of data values. Imagine comparing the heights of oak trees in a forest. Each tree's height contributes to the overall picture. Knowing the average height is useful, but it doesn't tell the whole story. The average might hide significant differences. Some trees might be towering giants, while others are mere saplings. This variation is crucial for understanding the forest's structure. Standard deviation helps us quantify this variation, providing a more nuanced perspective. It tells us how much the individual data points deviate from the mean. In essence, standard deviation measures how spread out our data is. It gives us a clearer picture of the data's overall distribution. A high standard deviation indicates wide variation, while a low standard deviation suggests that data points cluster closely around the mean. This information is vital for accurate data interpretation. This simple yet powerful concept has profound implications across numerous fields. From finance to biology, understanding standard deviation helps us make better decisions and predictions. Standard deviation, often represented by the Greek letter sigma, is a statistical measure that quantifies the amount of variation or dispersion in a set of data values. It is a fundamental concept in the field of statistics and is widely used in various disciplines. In simpler terms, it tells us how much individual data points deviate from the average or mean value of the entire data set. This deviation can provide insights into the consistency and reliability of the data. A low standard deviation indicates that the data points are clustered closely around the mean, suggesting a relatively homogeneous data set. This means that the values are quite similar to each other. Conversely, a high standard deviation implies that the data points are spread out over a wider range, indicating greater variability within the dataset. This suggests that the values are more diverse. Consider the heights of students in a classroom. This is a practical example to understand the concept better. If all the students are roughly the same height, the standard deviation would be small. This indicates that there is little variation in their heights. However, if there is a mix of very tall and very short students, the standard deviation would be larger. This shows a significant variation in the heights. Understanding standard deviation is crucial for interpreting data and drawing meaningful conclusions. It helps in assessing the spread and reliability of the data. It provides context to the average, helping us assess the reliability and significance of our observations. By understanding the spread of data, we can make more informed decisions and predictions. Calculating the standard deviation might seem daunting at first glance, but it is a straightforward process involving a few key steps. Let's break down the formula and demystify the calculation. Step 1. Calculate the mean or average. The mean is simply the sum of all data points divided by the number of data points. Step 2. Calculate the variance. For each data point, subtract the mean and square the result. Then, sum up all the squared differences. Finally, divide this sum by the number of data points minus 1. Step 3. Calculate the standard deviation. The standard deviation is simply the square root of the variance. While the formula might seem complex, it essentially measures the average distance of each data point from the mean. By following these steps, we can quantify the spread of our data and gain deeper insights. The concept of standard deviation might seem abstract, but it has numerous applications in our daily lives. It helps us understand the variability or spread in a set of data, which can be crucial for making informed decisions. Let's explore a couple of everyday examples to illustrate its relevance. Example 1. Picnic planning. This is a scenario many of us can relate to. Imagine you're planning a picnic for your friends and want to buy drinks. You need to consider the weather to ensure everyone stays comfortable. You know the average temperature will be around 80 degrees Fahrenheit, but the standard deviation is high, around 15 degrees. This means the temperature can vary significantly. This tells you that the temperature could be anywhere from the mid-60s to the mid-90s. Such a wide range requires careful planning. In this case, it's wise to buy a variety of drinks, including some that are refreshing on hot days and others that are more suitable for cooler temperatures. This way, you can cater to everyone's needs regardless of the weather. Example 2. Penguin huddles. Emperor penguins in Antarctica huddle together for warmth during the harsh winters. This behavior is a fascinating example of how animals adapt to extreme conditions. The penguins on the outer edge of the huddle are exposed to the coldest temperatures, while those in the center are warmer. This creates a natural rotation system. The standard deviation of the penguins' positions within the huddle would be a measure of how tightly packed they are. A higher standard deviation would indicate a looser formation. A smaller standard deviation indicates a denser huddle, which helps them conserve heat more effectively. This tight packing is crucial for their survival in the freezing temperatures. These examples demonstrate how standard deviation helps us make informed decisions and understand natural phenomena by considering the spread of data. Whether it's planning a picnic or understanding animal behavior, this statistical measure is incredibly useful. Section 5. Education grading on a curve. In the realm of education, standard deviation plays a crucial role in evaluating student performance and ensuring fair assessments. One common application is grading on a curve, where the distribution of grades is adjusted based on the class's performance. Imagine a challenging exam where the average score is unusually low. In this case, a teacher might use standard deviation to curve the grades, awarding higher grades to students who scored above the mean, even if their raw scores were relatively low. Standard deviation also helps educators identify students who might need additional support or those who are excelling beyond expectations. By analyzing the distribution of test scores, teachers can tailor their instruction to meet the diverse needs of their students. Section 6. Finance, taming market volatility. The world of finance is rife with uncertainty and risk. Stock prices fluctuate constantly, interest rates rise and fall, and currencies experience volatile swings. In this turbulent environment, standard deviation serves as a vital tool for measuring and managing risk. Investors use standard deviation to assess the volatility of different assets, such as stocks or bonds. A high standard deviation indicates greater price fluctuations, suggesting a riskier investment. Conversely, a low standard deviation suggests a more stable investment with lower potential for dramatic gains or losses. Portfolio managers use standard deviation to construct diversified portfolios that balance risk and return. By combining assets with different levels of volatility, investors can potentially reduce their overall risk exposure without sacrificing returns. Section 7. Research, separating signal from noise. In scientific research, standard deviation helps researchers distinguish between meaningful patterns and random fluctuations. When analyzing experimental data, it's essential to determine whether observed differences between groups are statistically significant or simply due to chance. Standard deviation plays a key role in hypothesis testing, a statistical method used to evaluate the validity of a research hypothesis. By comparing the means and standard deviations of different groups, researchers can determine the likelihood that observed differences are genuine or merely random variations. For example, a medical researcher studying a new drug might use standard deviation to compare the recovery times of patients who received the drug versus those who received a placebo. A statistically significant difference in recovery times, as indicated by the standard deviations, would provide evidence to support the drug's effectiveness. Section 8. Beyond the numbers, the power of context. While standard deviation is a powerful statistical tool, it's essential to remember that it's just one piece of the puzzle. Interpreting standard deviation requires context and an understanding of the underlying data and the questions we are trying to answer. For example, a high standard deviation isn't always a bad thing. In some cases, it might indicate a diverse and interesting data set. Conversely, a low standard deviation might suggest a lack of variability, which could be problematic in certain situations. Ultimately, the meaning and significance of standard deviation depend on the specific context in which it's used. By considering the broader picture and applying critical thinking, we can harness the power of standard deviation to gain valuable insights from data. Section 9, Conclusion, Standard Deviation as a Guiding Light. In the vast ocean of data that surrounds us, standard deviation serves as a beacon, guiding us toward meaningful insights and helping us navigate the complexities of the world. By quantifying the spread of data, it provides context to averages, reveals hidden patterns, and empowers us to make informed decisions. From education to finance, from research to everyday life, standard deviation plays a pivotal role in shaping our understanding of the world. By embracing its power, we can unlock the secrets hidden within data and embark on a journey of discovery and enlightenment.